Okay, next question is a question I've taken from the revision guide. So this is page 51 of the revision guide, question 2. So have a look at that and try to work through all your revision guide questions, but this is one that I'll talk you through. So what have we got? We've got our reaction is 2NO2 going to 2NO and O2, and it's giving you the amounts of the reactants and products in grams. So we've got 34.5 grams of NO2 was heated. It's giving you a volume and temperature, and it says 7.04 grams of O2 was present in the equilibrium mix. So part 1, calculate the number of moles of everything in the equilibrium mix. Okay, so we can use our rice table, and I've already written out the reaction. So the next thing we need to do is work out how many moles 34.5 grams of NO2 is. So moles is equal to mass over MR, mass over MR. So we've got our mass of 34.5 and our MR is 46. The MR of NO2 is 46. So that's equal to 0.75 moles. So we've got our initial moles of NO2 is 0.75. Okay? So the next one we need to work out is our moles of oxygen present in the equilibrium mix, because we've got 0 moles of O2 present to start. So we're going to do mass over Mr again. So we've got this is for NO2, and so for O2 we've got 7.04 all over 32, because we've got 16 times 2 is 32, and we've got 0.22, that equals 0.22 moles. So that's how many moles of oxygen we've got in the equilibrium mixture. Oh, sorry, I just dropped one of my pens. So 0.22. So that means there's been a change of plus 0.22 for oxygen. Now we're going to use our stoichiometry. So NO to O2 is 2 lots of NO to 1 lot of O2. So we're going to do 0.22 times by 2. So that's going to have gone up 0.44 from 0. So it's going to be 0.44 moles at equilibrium. Okay, so it's gone from 0. It's one of the products. Here the stoichiometry NO2 to NO is 2 to 2 or 1 to 1. So again, that's going to have decreased by 0.44. So the equilibrium number of moles at equilibrium of NO2 is 0.31. So 0.75 minus 0.44, that is 44, not 94. I know when 4 sort of look like 9 sometimes. Okay, so you've calculated the number of moles of everything in the equilibrium mixture. 0.31 moles, 0.44 moles, 0.22 moles. And now it says derive Kc. So all we have to do for that is, let's write out the expression just using the formula for now. So Kc is equal to products over reactants. So products, we've got NO, concentration of NO raised to the power of 2, because it's 2 moles of it, times by the concentration of O2, all over the concentration of NO2 raised to the power of 2, all squared, because there's 2 moles of that. Okay, so now we can put our actual numbers in. Kc is equal to NO, so we've got 0.44 divided by our volume, which is already in decimeters cubed, which is great. We don't even have to change it, squared, times by our moles of oxygen over 9.80. I know I'm going off on the wonk of it because of the way I'm standing, but hopefully you can still see that. All over NO2, which is 0.31, over 9.80, again, squared. Okay, so if you actually put the numbers in, if you do these, and like I say, it's better to do these calculations individually than put it all into your calculator, because if you just put it all into your calculator, it's so much easier to make a mistake. Then you might not always go back and check, although you should if you have time, obviously, but you might not have time. So if you've done these individual bits, we've got 0.0222 over, times by 0.0019 all over 0.0009. I'm not using standard form for some reason, I just haven't written that down in my notes. But obviously in your calculator it will give you standard form, and that is equal to 0.046. And let's have a look at the units. So for units, we're going to have moles, decimeters cubed, moles, decimeters cubed, moles per decimeters cubed. 3 lots on the top, 1, 2, 3, and 2 lots on the bottom. Let's cancel those down, and we're left with moles dm cubed. Okay, and that's the answer, 0.046 moles per decimeters cubed. Okay, so that is a really good practice question, because it's essentially asking you everything. It's asking you to work out moles from mass, it's asking you to calculate equilibrium moles, and when the stoichiometry isn't 1-to-1 ratio, and then it's asking you to calculate Kc, and it's asking you to calculate units where there are units there. So that's a really, really good question to do. Okay, so the last video I'm going to come on to is just a very last little bit of this topic, and then we're finished and I'll move on to redox. Okay, thanks.